Okay, synthetic division. It is a nice, pretty fun way to divide. The problem is you can't always use synthetic division. You can only use synthetic division if you have a polynomial, some p of x, that's being divided by something of the form x minus c. When it's being divided by something of that form, then we can use synthetic. So, first, before we dive into it, let's make sure we understand the x minus c expression. Let's say we've got some polynomial p of x, and it's being divided by x plus 7, x minus 8, x plus 12, x plus 10, x minus 4. As we've seen many times in this class, when we're working with formulas and it's written with the negative, you have to take the opposite of what it looks like. So our job here is to identify what would c, the value of c, be in each of these cases. So since it's written with the negative, we must take the opposite of what it looks like. So in this case, c would be negative 7. In this case, c would be exactly what it looks like, 8. C would be negative 12, C would be negative 10, and C would be 4. That's how you would identify C. So in the last video, we did a long division example that we could have actually used synthetic for. So I'm gonna look at that one again. We had, they asked us to divide 5x cubed plus 2x minus 5 divided by x plus 1. Only when I gave it to you last time, I wrote it like a fraction. Every fraction that you ever see is a division problem. It's the numerator divided by the denominator. I chose to write it this time, this way, this time. So anyway, this we say, oh, I want to divide this. Can I use synthetic? Is what I'm dividing by in the form x minus c, and it is. So in this case, c would be negative 1. Now, just for simplicity, I chose to use whole numbers. C is not obligated to be a nice whole number. It could be a fraction or decimal or something crazy. But just to learn the method, we want to stick with something that's not too complicated. Okay, so this is how you would use synthetic division for this. You write down C, the value of C here. And then you write down a big kind of long L. And what's going to go in here are 2 columns of numbers. The top column is the coefficients of the polynomial that you're dividing into. But if you look at this guy, he is missing this term, this x squared term, so we still have to put in a placeholder. That way we're adding up like terms. So my coefficients here will be 5, 0, 2, negative 5, just like that. Okay. So here's how you use synthetic. First thing you do is you just bring down the first number to get things started. So we bring down the 5. And then the next operation is to multiply up. So we'll multiply up. 5 times negative 1 is negative 5. And that goes in this position. Then we add down. So the rest of the time, we're going to be adding down. Okay, so what do? We brought down the 5. Then we multiplied up. 5 times negative 1 is negative 5. Then we add. 0 plus negative 5 is a negative 5. Then we multiply. Negative 5 times negative 1 is a 5. Put the 5 right there. Then we add. 2 plus 5 is 7. Then we multiply. 7 times negative 1 is negative 7, and then we add negative 7 plus negative 5 is negative 12. Now, here's our numbers. What does this mean? Well, now we interpret what this means. This last term is your remainder. This is your constant term, or x to the 0 power term. This is your x term, x to the 1. This is your x squared. If we had more numbers, we would go x cubed, x to the 4th, and so on. What this means is that this polynomial divided by this polynomial is equal to, right here, 5x squared, 5x squared minus 5x plus 7x to the 0, or just 7, minus the remainder divided by what I'm dividing by, x plus 1. So that is one that we saw in the last example. We're just going to do a couple more synthetic divisions to make sure we're good at it. Then we will begin our remainder theorem and factor theorem that we need to see. Okay, so let us do another example. How about this? Let's long divide. Let's use synthetic division to divide this. X cubed minus plus 27 divided by x plus 3. And hopefully you're seeing some similarities here. This is also sum of cubes. When we get done with this, hopefully you'll recognize it. But first we'll just say, oh, can I use synthetic division here? Dividing this polynomial by this one. Oh, this is in the right form. What would c be in this case? C would be negative 3. So we got, okay, negative 3. Put that there and draw your big long L. Then you put in the coefficients of the polynomial you're dividing into. X cubed is 1. Uh-oh, I'm missing x squared term plus x 0x squared. I'm missing an x term plus 0x. I put those guys in there. So 1, 0, 0, and 27. Those are the coefficients for that. Bring the first guy down, 1. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. Multiply up. Negative 3 times negative 3 is 9. 0 plus 9 is 9. 9 times negative 3 is negative 27. So 27 plus negative 27 is 0. Now, these are our numbers. Let's interpret. This is remainder, x to the 0, x to the 1, x squared. That means that, let me just see, x cubed plus 27 divided by x plus 3 is equal to 1x squared minus 3 times x plus 9, and there was no remainder. You can see that if I multiplied both sides of this equation by this denominator, x plus 3, I would get that x cubed plus 27 is this, which is sum of cubes factorization. Okay, let's do another synthetic and then we'll be done with synthetic. Let's divide, I don't know, let's make this up. How about 15x to the 4th minus 2x squared plus 11 divided by x minus 2. Let's do that one. All right. First, can I use synthetic? Well, I'm dividing by x minus 2. That fits that form. Yes, I can. So in this case, c would be equal to 2 because you take the opposite of what it looks like. So write down your c. Draw your big long L. Put the coefficients out there. Put your placeholders in if you need to. So like 15x to the 4th, 0 x cubed, negative 2 x squared, 0 x, 11 is my remainder. Let's just begin. Bring down your 15. Multiply up. 15 times 2 is 30. 0 plus 30 is 30. 30 times 2 is 60. Negative 2 plus 60 is a 58. 58 times 2 is 116. 0 plus 116 is 116. 116 times 2 is 232. 11 plus 232 is 243. Now I did that a little bit fast. I just want to double check my addition. 15, 30, 30, 60, 58, 116, 232, 2, okay, I think that's okay. Let's interpret this now. This is going to be my remainder. X to the 0, x to the 1, x to the 2, x to the 3. So what I can say is that this polynomial divided by this polynomial right here, right, is equal to 15 x cubed plus 30 x squared plus 58 x plus 116 plus my remainder is 243 divided by x minus 2. That's the official way to write that. All right, synthetic.